Hello. Today, welcome. April 2nd, 2020. Writing equations of power functions is going to be our topic. So, as of right now, we can graph power functions. Most people did the quick Google Forms quiz. Still waiting on a few, but it's due today, actually, by noon. So, you still have 2.5 hours, roughly. So, anyway, hopefully, you're going to get that in today. We're going to write the equations. So, basically, the idea is if you're given a graph or a table or something, how would you write a power function that describes those ordered pairs? So I'm going to walk through one of these examples with you. We're just going to go scroll down here. So I guess a little brief sort of scenario that we can kind of hit. What would these things look like? And, positive and even p. So we're talking about something to the second, fourth, sixth, eighth, 10th, 12th, so on and so forth. We know that basically that's going to resemble a parabola. And k greater than 0 just means concave up. So the k greater than 0 part, we're going to have concave up, and the p even and positive, we're going to have basically the idea of a parabola. So I'm going to draw that right there, and that is our first scenario. That was the upper left corner of our notes. Upper right here, this guy, p is even and negative and k is greater than 0. That is one of my favorite graphs ever. The Atari symbol, the volcano, however you want to think about it. Okay, those are those. And now p is odd and positive. That's going to be the classic cubic. K is greater than 0 on all of these, so I'm not going to keep saying it. And then p is odd and negative. That's going to be our hyperbola. All right, so we're looking at those graphs. Those are our basic standard graphs. Everything else is just going to be a transformation of those. All right, so counting boxes. So again, just to reiterate the stuff that we've been talking about since October, November, the idea is you understand a couple of the basics, and then we count boxes to move them. We multiply to stretch them. We negate to reflect. So on and so forth. All right, same stuff, different day, different function. All righty, let's see if we can get it. All right, here's a problem. Let's get them. So we got this graph given to us. Determine the equation given the graph below. We got a bunch of ordered pairs, and we have this sort of downward abyss-looking thing. So what does that tell me? It tells me that I am in this scenario right here. All right, so I'm talking about a graph where p is even and p is negative. Okay, so p is even and p is negative. So going to go back to this, and then I'm going to write. I just need some information. So let's see. I can quickly draw on this thing here. All right, so 0, negative 2 is a point, and 0, negative 2, and 1, negative 5. And then we've got 3, negative 5, and 4, comma, negative 2. So what does this tell us? Ooh, and actually drew that slightly wrong. Okay, so I'm gonna go to the big screen. We got all the ordered pairs that we need, and then we can actually talk about this thing. All right, so that's how my graph looks. So we know some things. Well, as I was just saying, we know that we're in this case right here. This case meaning that p is even and negative. So the gist is starting off with my basic power function, y equals kx to the p. I know that I'm going to jot this off to the side. P is negative. I'm also going to know that p is even based on the overall shape. All right. So what did we do to this graph, well, it looks like it was shifted right, down, and reflected. All right, so our graph looks something like this. Right, down, reflected. So we got to think, all right, how does this play in terms of writing an equation? All right, pretty easily, actually. I'm going to draw in the asymptotes. Vertical asymptote is x equals 2. So what does that mean from your power functions chart, which I'm still waiting on 4 people to turn in? It means that if the graph was shifted from the original OG graph that we showed you 2 times now on the front of this little slider, or dry erase board. So the gist is that if the original graph looks like this, then this graph has been shifted right 2, down 1. So that means we start with our equation right here. Very nice and easy. I have gone right 2, down 1. Okay? Now, if I leave it like this, p is going to work out to be a negative number. Some people in previous years have preferred to write this in the denominator because that's what it looks like in their chart. Either way is 100% fine for me. I think this problem I'll stick with what I wrote originally. The next problem I'll do it with moving things to the denominator. Alrighty? So let's see what information we have. I've got some ordered pairs. I've got 0, -2. I've got 1, -5. I've got 1, 2, 3, 4, -2. And 3, -5. So I've got 4 ordered pairs, and I have an equation for which I have 2 variables that I need to solve. So 1 equation, 2 variables, impossible to solve. I'm going to go back here real quick and just make sure my ordered pairs are right. 0, -2, 1, -5, 3, -5, and 4, -2. All right, so we're all good. Okay. So the only thing we can do with ordered pairs is plug them in, but we got to be smart about this. When I raise something to a power, obviously the value of that thing changes. So again, if I plug a 0 in, I'll do this for you just so you can see what is going to happen. I know that when x is 0, y is equal to -2. So if I replace these values, okay, well, I can add 1 to both sides. So I can go here. And now I can see this clear as day that we are stuck because all we know is that p is even. Well, if p is equal to, and negative, so if p is equal to -2 versus -4 versus -6 versus -8, then -2 to those aforementioned powers are all different numbers. So how do I determine what k is? And that's a rhetorical question. You can't, because -2 to the p matters. Knowing the p matters. So this is not a good point to pick. All right, it's subtle. All right, but 0, -2, no bueno. Same thing, we're going to X out 4, -2 as well, because if I plug a 4 in here, I get 4 minus 2, which is 2. 2 to a power is, well, whatever the power is going to dictate that value. So what we got to think here is there a number that when I raise it to a power, I get back the number? And you're like, wait, what? 0 to the 5th? That's 0. So if I can get a 0 in here, that'd be great. Well, if we have a 0 in here, then that zeroes out everything. And then it just gives us 0, -2 back. Okay? So not going to help us. Alrighty? Or sorry, if it was 2 in here, it would give us 0. So that's not going to help us at all. But the gist is there another number that when I raise to a power, I get the same number back? Well, yeah. 1 cubed is 1. 1 to the -18th, still 1. So if I can get, the logic here is, can I pick one of these 2 points that are left over so that when I plug it in, x minus 2 will equal 1? All right? Or -1 if you really matter, or if you want to. It doesn't really matter. But I think I'm going to go with the easy one to start this problem off. I'm going to pick 3, -5 as my ordered pair. Why would we do this? I'm going to keep on saying it over and over and over again. I have 2 variables and only 1 equation. That is an impossible case to solve accurately for both of those variables. Here we go, though. If I choose wisely 3, -5, 3 goes in for x, -5 goes in for y. Oh, 3 minus 2 is equal to 1. This allows us to bypass the fact of the need to know p. P could be anything under the sun. 1 to that power is still 1. All right. There is no ifs, ands, or buts about that. So therefore, what I've done is I've chosen wise enough. And yes, all problems will be set up like this. All right. They'll be a little bit contrived because otherwise we can't write equations. The idea is I have to pick an ordered pair that's given to me on the graph so that I get a 1 in parentheses, or if you were being slick, a -1. The only problem with the -1 is, they're even, so it doesn't really matter at all. But I have a 1. If p were odd, then -1 to an odd power is -1, not +1. So that's the only thing I was alluding to. So now we're just going to do the math. I have -5 plus 1 is -4 is equal to k times 1 to the p. So that's k. So we found k. If I know k, I have one of the variables knocked out of this equation. Now, any of these other points are perfectly fine. I am not going to pick the point that I used, and therefore I'm not going to pick the counterpart to that point. I'm going to choose one of the things that we chose to X out originally. Alrighty. So if I do this, let me just adjust this real quick. See if I can get enough room. I have k is equal to -4. So therefore my function looks like this. Notice how I keep the transformations in there. All right, we're starting with this, and then we're going right here with the transformations. Then we're solving, and then finally we're solving for the last variable. So it's a 4-step process. Those of you that are memorizers, please don't be, but if you are, then, I can't stop you. So I'm going to pick 4, -2. Here we go. 4 minus 2 is 2. I'm going to add 1 to both sides, and I'm going to get -1 is equal to -4 times 2 to the p. Okay, going right up here. -1 divided by -4 is +1/4, and that's equal to 2 to the p. Now, some of you are like, oh, should I do logs? Well, I'm hoping, since you're pre-calc students, that you know 2 to what power will give you 4. Okay, that's all we're doing here. So 2 to what power will give you 1/4 -2. And we are done. We have found both the k and the p. I guess there is a 5th step. Maybe we're not done. The last thing is to actually just write the equation, which would be -4 quantity x minus 2 to the -2 minus 1. And that is the overall answer. Alrighty. Again, you can pause those videos and rewatch them too. All right, we're going to do another one here. I'm going to give a little bit of time to erase. All right, I'm going to leave this up here for another quick sec so you guys can take a look at it, follow all the steps. All right, move this guy out of the way. I don't know if it records for you. But that's the basic gist. We just have to choose wisely on step number 3. Okay, so that's a really good way to do this. It also uses our transformations, which we've been doing since October or November. Okay, the next problem. We got this scenario right here. That resembles this graph. All right, so what do I know about that graph? Well, I know that P is odd, and I know that P is negative. Alrighty, P is odd, and P is negative. So my picture here looks similar to that. It's just been transformed. Okie doke. So I'm going to leave that up there. I'm going to erase my board, and then we're going to have at it. Alrighty. Graph this thing. All right. What do we have? We have 6, 3, 10s. Here we go. It looks like a vertical asymptote at x equals 1. So draw that in dotted. Vertical asymptotes, any asymptotes, always draw it in dotted. Please and thank you. All right, it looks like my horizontal asymptote is y equals 4. So I'll draw this up here. It's the y-axis, that's the x-axis. Here's y equals 4. All right, so what does this graph look like? I got the point 2, -1. So I'm hitting that guy, and then 6 comma 3. So 2, 3, 4, 5, 6. 1, 2, 3. So there's this graph right here. And then I got some other guy living way up here. Am I crossing the x-axis? Yes. Or the y-axis? Yes, I am. All right. So nothing really useful in this part of the graph. All of my ordered pairs are right here. So what am I going to do? I'm trying to write a power function, folks. This is where the chart came into play. Again, 4 of you still owe me that chart. It is huge. Actually, you owe it to yourself. It's a reference sheet you can have out when you do all of these problems, and it keeps the guessing to a minimum, and then it gets you in your brains, and you understand that we're just looking at overall parent functions or shells, and then just transforming them. All right, so y equals kx to the p. Well, how do we do this? Well, there's a power function. Okay, the original OG graph was the one that we just looked at here. And we'll go back, get out of that screen. It's this guy right here, but it looks like it's been transformed. So it looks like it's upside down. So that means it's been reflected. So what do I know? I know that k is going to work out to be a negative number. I know from previous things that p is odd and p is negative. So those are the things I need to solve for. And I know that the original graph based on your charts, which 4 people still owe me, the original asymptotes were the y and x-axis. My new asymptotes are not the y and x-axis anymore, but instead x equals 1 and y equals 4. So the vertical asymptote was shifted from the y-axis over 1 unit. So here we go. To shift to the right 1 unit, I know I need it to look like that. To shift up 4 units, I know I need to tack on a plus 4. So this is where we're starting off. This is going to be the format for my equation. And I do know that p is negative. So I said for this particular example, I would do it the way that usually 50% of the class prefers. And I would do that. So now when I solve, I'm expecting to get a negative value for k, but now I'm expecting, since I've already put the quantity x minus 1 in the denominator, I'm expecting p to come out to be an odd positive number now. If I leave it up here in the numerator, I would expect p to be odd and negative. All right? That's like saying that 2 to the negative second is the same as 1 over 2 squared. Okay? Here, I'll use odds just to make sure that you're not losing me. But that's the exact same idea that we're looking at. Nothing scary. So please pay attention to that easy fact. Okay. I have ordered pairs 2, negative 1, and 1, 2, 3, 4, 5, 6, comma 3. Okay. So all I got to do is plug and chug. And it's the exact same routine that we did last time. If I plug a 6 into here, I get 6 minus 1, which is 5. 5 to a power matters. That power definitely matters, knowing that value of p, because 5 squared is 25, 5 cubed is 125. 5 to the, well, these are odds. So 5 cubed versus 5 to the 5th versus 5. So those are all drastically different numbers. So we're going to pick 2 comma negative 1 to start off with. Why? Well, to reiterate this, negative 1 is a y value. K, I don't know yet. And that was pun intended, by the way. Y, negative 1. Great. So the now WHY is, why would I plug a 2 in here? Why would that help my cause? Well, it eliminates the fact of needing to know what p is, because again, check it out. I've got 2 minus 1, which is 1. 1 to any power is just 1. So now, this is the math problem that I am solving. All right, I'm going to subtract 4 from both sides, and I'm going to have what k is easily. Okay, so this one, useless to us now. We've already sucked out all the information. Now I'm going to go play with 6 comma 3, and I'm going to do the exact same thing. 3 is a y value. K is whatever. Oh, no, k we know is negative 5. And then 6 goes in for x. And then I've got a plus 4. All right, so we're going back to here. I now know what k is, so I fill it in. Actually, we're going back to here. I now know what k is, so I fill it in. And then now I fill in my x and y's, and now here we go. So I'm going to subtract 4, and I'm going to get negative 1. And I'm going to get this value right here. So you can cross multiply, you can clear the denominator. You could do this a lot easier, but I'm not going to because it's online learning as it is, and I want to make sure you understand what's going on here. So here's what we're looking at. The brain buster. Negative 1 times 5 to the p is negative quantity 5 to the p. And then the result is equal to negative 5. So how do we figure this out? Well, 5 to what power will give you 5? I'm hoping everybody is saying 1. Okay. And now, last but not least, you just have to write your equation, which is going to be negative 5 all over x minus 1 plus 4. And there you go. Quarter boy, get out of there. All right, there'll be more to follow, but if you guys watch this video, that'd be great. Yeah, signing off. Take it easy. Check you later.